Hello everyone. In this AV we are going to solve some of the numericals of the chapter Motion in One Dimension. So we will be first solving exercise 2A and we would be doing at least one question of each type. So in exercise 2A, the first question is the speed of a car is 72 km per hour. Express it in meter per second. So we have the speed given to us in kilometer per hour. So 72 km per hour. So we can write it as 72 upon per hour means 1 hour. So for kilometer to meter conversion, we know that we multiply it with 1000, and from hour, when we go to second, we have to multiply it with 60 into 60. So here you see it's 72 into 1000 and 60 into 60 is 3600. Please remember that when we have to convert from kilometer per hour to meter per second, then we multiply the given number by 1000 upon 3600. If it's the opposite, like we have to if we have to convert from meter per second to to kilometer per hour, then it would just be the reciprocal. That is, it would be, then you multiply it with 3600 upon 1000. So here when we simplify it, we get the answer as 20 meter per second, because here we can cancel out the zeros, and 36(1) and 36(2) is 72, so 2 into 10 is 20. So we have 20 meter per second. This is how we convert kilometer per hour to meter per second. In case it's the other way around, you just flip this 2, then it would be 3600 by 1000 multiplied by the given number. This is the way to convert meter per second to kilometer per hour. Now we go to the next type of question, that is question number 5. It says a train takes 3 hours to travel from Agra to Delhi with a uniform speed of 65 km per hour. Find the distance between the two cities. So first of all, we will write the given things and then the appropriate formula. So here we have written the given things, that is, it's given in the question that speed is 65 km per hour and time that it takes is 3 hours. So we have to find out the distance. We know that the formula for distance is equal to speed multiplied by time. We have been provided with the speed, that is 65, multiplied by the time, that is 3. So when we multiply it, we find 5 into 3 is 15, 18, 1, 19. So 195, and the unit would be kilometer. So here the answer is 195 kilometer. Now we go to the next question, that is question number 6. It says a car travels first 30 kilometers with uniform speed of 60 km per hour and then next 30 km with a uniform speed of 40 km per hour. And we have to calculate the total time of the journey and average speed of the car. So first we will find out the individual time taken for the first 30 kilometers with the speed of 60 km per hour, and then we'll find the time for the next 30 kilometers with a uniform speed of 40 kilometers, and we will add both the times. That's how we'll get the first part. And for the second part, average speed of the car is total distance divided by the total time. So total time we will be taking out in the first part, and total distance is nothing but 30 km plus 30 kilometers, that is 60 kilometers. So let's write the given things. So here we have written the given things. For the first 30 kilometers, distance is 30 kilometers, speed is 60 kilometer per hour. So we know we are using the same formula, distance is equal to speed multiplied by time. So this is for the first 30 kilometers, so we are writing time as t1. So from this formula, time will be equal to speed going that side, distance upon speed. So the distance covered is 30 kilometer per hour, 30 kilometer, and the speed is 60 kilometer per hour. So here we will get 1 by 2 hour. Half hour is nothing but 30 minutes. Similarly, for the next part, for the next 30 kilometer, we have the same thing. We simply write time t2 is equal to, again, distance upon speed, that is equal to, here the distance covered is 30 kilometers, but the speed is 40 kilometer per hour. So kilometer and kilometer per hour. So here it will be 3/4 hour, that is nothing but 45 minutes. So the first part of the solution, total time is nothing but t1 plus t2, that is 30 minutes plus 45 minutes, it comes to 75 minutes. And the next part of the question is to find the average speed of the car. So we know average speed is equal to total distance upon total time. So total distance is 30 plus 30, that is 60 kilometer, and so the total distance is 60 kilometers, and total time here it's 75 minutes. So that will be converted to hours. So you can divide it by 60, or you can add 3 by 4 plus 1 by 2, because these two are in hours. So that we will get it as 1.25. So here kilometer per hour. So after division we will get 48 kilometer per hour. That's the average speed. So this is the answer. Now we come to question number 7, which says a train takes 2 hours to reach station B from station A, and then 3 hours to return from station B to A. The distance between the two stations is 200 kilometers. Find the average speed, and number 2, the average velocity of the train. Here the average speed can be found out same as we did in the previous question. And for the second one, that is average velocity of the train, please remember that average velocity is given by the displacement upon total time. So here this is the scenario. We have two stations, station A and station B. The train is going to station B as stated in 2 hours for going and 3 hours for coming back. So for the first part, we will calculate the total distance, that is the distance between A and B is 200 kilometers. So here the train is covering 200 kilometer plus 200 kilometer, 200 while going and 200 while coming. So total distance is 400 kilometers, and the total time would be 2 hours plus 3 hours. So that will give us the average speed. But for the average velocity, please see here that the train is starting from point A and it's going to point B and then again coming back to point A. So therefore the displacement is 0. There is no displacement. That is why the second part of the question, the average velocity of the train will be 0. Why? The reason is there is no displacement. So let's solve it. We first write the given things. Total distance is 200 plus 200, that is 400 kilometers, and total time is 2 hours plus 3 hours, that is 5 hours. Now for the first part, we have to calculate the average speed. So average speed is equal to total distance upon total time. So here we have already calculated the total distance is 400 kilometers and the total time is 5 hours. So when you divide it, you will get the answer. 5 into 8 is 40, so 80 kilometers per hour. This is the answer for the first part. And for the second part, as I told you, the average velocity of the train is 0 as the displacement is 0, because the formula for average velocity is total displacement upon total time. So displacement is 0, so 0 upon anything will still give us 0. Now we come to question number 9, which states that a body starts from rest and acquires a velocity 10 meter per second in 2 seconds. Find the acceleration. So first of all, here we have to find the acceleration, and we know that the formula for acceleration is final velocity. Acceleration is equal to final velocity minus initial velocity upon time taken. So before using the formula, we will just write the given things. So here the things that are given to us is the body starts from rest. That means initial velocity, that is u, is 0, and acquires a velocity 10 meter per second. That means our final velocity v becomes 10 meter per second, and the time is 2 seconds. So we have to find the acceleration. So we know the formula for acceleration, that is acceleration is equal to final velocity minus initial velocity upon time taken. So we have the values. Final velocity is 10, initial velocity is 0, and time taken is 2 seconds. So 10 minus 0 is 10 upon 2, that is nothing but 5 meter per second square. So this is our answer. Now we come to question number 12. Question number 12 states, a toy car initially moving with uniform velocity of 18 km per hour comes to a stop in 2 seconds. Find the retardation of the car in its SI units. Now here there is a trap. They have given us the velocity of the car in kilometer per hour but time in seconds, and they have asked us to find the retardation in its SI unit. So the retardation is nothing but negative acceleration, and the SI unit is meter per second square. Now what we will do is we will have to convert this 18 kilometer into meter per second. So after conversion it would come to 5 meter per second. Let's do it. Let's write the given things. So here, what are the things given to us? Initially moving with the uniform velocity 18 kilometer per hour. So initial velocity U is 18 kilometer per hour. I have already told you while solving question number 1 how to convert it. So this is equal to 18 into, from kilometer to meter, it's 1000 divided by 3600. So after simplifying we will get 5 meter per second, and it comes to a stop, means the final velocity V is 0 because it's coming to a stop, and the time taken, time is equal to 2 seconds. So we have to find the retardation. So here retardation, or we can write acceleration also. As it is, we are going to get the result in minus. So retardation is final velocity minus initial velocity upon time. So that is, retardation is nothing but negative acceleration, please remember. So here final velocity is 0 minus initial velocity is 5 meter per second, and the time taken is 2. So 0 minus 5 is minus 5 upon 2. When you divide, you will get minus 2.5 meter per second square. Please remember, the negative sign indicates retardation. So this is the answer. Either we can write acceleration is minus 2.5, or we can simply write that retardation is 2.5 meter per second square. Now we come to question number 13. Question number 13 says, a car accelerates at the rate of 5 meter per second square. Find the increase in its velocity in 2 seconds. So we have to find its final velocity that it will acquire in 2 seconds. So we write the given things. So we have written the given things. Acceleration is given as 5 meter per second square and time taken is 2 seconds. So we know that acceleration is nothing but change in velocity upon time taken, and change in velocity is nothing but final velocity minus initial velocity upon time taken. So acceleration is given to us as 5 meter per second square, and we have to find the final velocity v. Initial velocity is 0 upon time taken is 2 seconds. So we simply write 2 seconds. When we cross multiply, we will get the final velocity as 5 into 2, that is 10 meter per second. This is the answer. Final velocity is 10 meter per second. Now we come to the next question, that is question number 14. It says, a car is moving with a velocity 20 meter per second. The brakes are applied to retard it at a rate of 2 meter per second square. What will be the velocity after 5 seconds of applying the brakes? So here we have written the given things. Final velocity we have to find out. Initial velocity is 20 meter per second. Retardation is 2 meter per second square. Time is 5 seconds. So we will use the formula. We know acceleration is equal to v minus u upon t. Here our acceleration is retardation and that is 2 meter per second square. So we will take it with minus sign. Negative sign indicates it's retardation. Then we have to find out the final velocity. Initially it was moving with 20 meter per second and the time is 5. So when we cross multiply, this implies 5 into minus 2 is minus 10 is equal to v minus 20, or simply v will be equal to minus 20 going this side becomes plus 20. So we have minus 10 plus 20. So it comes to final velocity is plus 10 meter per second. This is the answer. We go to the next question. Question number 15 says a bicycle initially moving with a velocity of 5 meter per second accelerates for 5 seconds at the rate of 2 meter per second square. What will be its final velocity? It can be done exactly like number 14. So we will write the given things first. So here we have written the given things. Initial velocity is 5 meter per second. Time taken is 5 seconds. Acceleration is 2 meter per second square. Final velocity is what we have to find out. So we know the formula. Acceleration is change in velocity upon time. So acceleration given to us is 2 meter per second square multiplied by final velocity we have to find out. Initial velocity is 5 meter per second and the time taken is again 5. So when we cross multiply, 5 into 2 is 10 is equal to v minus 5. Minus 5 coming this side, it becomes 10 plus 5 is v, or the final velocity v is 15 meter per second. This is the answer. Now we go to the last question of this exercise 2a. It says a car is moving in a straight line with speed 18 km per hour. It is stopped in 5 seconds by applying the brakes. Find the speed of the car in meter per second, the retardation and the speed of the car after 2 seconds of applying the brake. So for the first part, 18 km per hour, we simply have to, this is the speed and we simply have to convert it in meter per second. So the speed of the car in meter per second is, so the speed is given, we simply have to convert it into meter per second. So we have written speed of the car in meter per second is 18 into 1000 divided by 3600. When you simplify, you'll find it to be 5 meter per second. Okay. Now the second part of the question is we have to find the retardation. So we know acceleration is given as final velocity minus initial velocity upon time taken. So we write the values. Acceleration is what we have to find out. So final velocity, finally it's coming to stop. So that is 0 minus initial velocity we have calculated 5 meter per second. And the time taken for achieving this is again 5. So it is minus 1 meter per second. So now here also the negative sign indicates retardation. So we can simply write the retardation is 1 meter per second square. Please put a square here. So it's 1 meter per second square. Now the third part of the question says we have to find the speed of the car after 2 seconds of applying the brakes, means the final velocity. So we will again use the formula acceleration is equal to change in velocity, that is v minus u upon t. Our acceleration is retardation, so we will write minus 1 is equal to final velocity we have to find, and the initial velocity we have been given, that is 5 meter per second, and the time it's given in the second part of the question, that is 2 seconds. So 2 into minus 1 is minus 2 is equal to v minus 5. So therefore v will be minus 5 going that side becomes plus 5, so that is equal to 3 meter per second. This is the final velocity. That's all in this AV. Thank you.